Hello, now we are going to look at bar charts. And bar charts are a type of graph we use for categorical type data, where we have groups of things and we want to see how often each group appears, but we have numbers that are too high to do conveniently with a line plot. So, if we have our number of goals scored in some soccer matches, we could have had 0 goals scored, and that happened 3 times. So there were 3 games where 0 goals were scored. There were 5 games where 1 goal was scored, and so on. So this is our frequency table, and now we're going to use this frequency table to draw our bar chart. So I already have my frequency axis set out. I can see that the highest frequency I need to get to is 15. And I have it labeled. I have frequency for the number of times I see something, and I've labeled it as the number of games. So the number of games that had our particular outcomes of goals. So then I need to break up my goals axis. And for a bar chart, we want to make sure that we leave a gap between each one of our bars. So I'm going to leave a gap from the axis, and I'm going to put 2 lines here, and I'm going to say that that's going to be my 0 group. This is going to be my 1 group, 2 group, 3 group, 4 group, and 5 group. I'm going to write them in now. So this is for 0 goals. This is for 1 goal. This is for 2 goals, 3 goals, 4 goals, and 5 goals. Now, if I look at how many times I got 0 goals, that was 3. So I'm going to go up 1, 2, 3, and that's how tall my bar is going to be for my 0 goals. I've gone neatly across a single box, and now I'm going to use a ruler to draw in the rest of the bar. So I have my bar drawn in. It is drawn neatly along the grid lines, so that's why I made my 0 group a box across, so that I'm able to use the grid lines on my page, on my copybook page, or on my exam page, to keep everything nice and neat and straight and orderly. These graphs are good for getting marks in an exam if we do them neatly. If we label what we're doing, and we break up our bars neatly, so leave a box in between each, keep all of our lines straight, make sure that it's very clear where our box stops, that I'm stopping dead at the 3 line. And the way that I did that was I have my numbers all going across the grid lines as well. I don't have my numbers sitting halfway across my box, and then it's very hard to tell exactly where I should write my 5. I'm using the grid lines to allow me to go straight across. If I have 6, I can go straight across at 6 along that grid line. And for my 8 bars, I'm just putting my ruler along the grid lines to get the sides of my bars for my bar chart. So now we're going to fill in the rest of this. I have to go up to 5 for my next group. So 5 times I got 1 goal. So I need to go up that high. So that is my box drawn in for having 1 goal. That happened 5 times, so my bar goes 5 high. I'm going to fill in the rest of them now. Now I have all of my boxes drawn in, and again, neatness is key. I'm using my grid lines to keep everything straight. All of them, I can see exactly how tall they need to be because I've put my numbers, my frequency numbers, across my grids on my page, and I've used a ruler to keep everything very neat. And if we don't do that, we lose a lot of marks, and we should be getting full marks for a graphing question like this. Now that we've drawn our bar chart, let's do some work based on it. What's the mode? So the mode is the modal number, or the most seen number. So modal number is another way you can see that called. Modal number. And that is very straightforwardly just going to be 2 for 2 goals. We got 2 goals a lot of the time. What's the median number? Well, the median number would be the number from smallest to biggest. The number from smallest to biggest. And then what's the middle of our data set when we've ordered from smallest to biggest. Now our frequency table orders from smallest to biggest automatically for us. We've gone from 0 up to 5. I could write this out and have 0, 0, 0, 5, and then 15 twos all out in a neat row. However, I can just work out the total number of games. So I'd have 3 plus 5 plus 15 plus 6 plus 0 plus 1. And in total, I would have, so in total I have 30 games that were played, and I add that up from my number number of games for each number of goals. So I have a total of 30. Now, if I think about a list of numbers as 30 long and I want to get exactly in the middle of it, the space between 15 and 16 is exactly in the middle of my group. So what I need to do is figure out what the 15th and 16th number in my list would be, and then I'm going to get the average of those two. So because I have 30 numbers total, if I imagine my list all going out along here, I would have 15 numbers above and 15 numbers below, but there wouldn't be a number here. So I'd need to get the 15th number and the 16th number, and I'm going to get the average of those two. So I need the average of the 15th and the 16th number. So we can always draw a picture out and figure out what would be the middle. If we have an odd number, we would actually have a middle number, and we'd have same number of numbers on both sides. For an even number, you won't have that. You'll be in between two numbers. You just get the average of those two numbers. Now, in this case, we know that we have to go up 15 from our first number, or down 15 from our top number. So we start here and we go, oh, well, 3 numbers and then 8 numbers, and then we would definitely be in the 15. So we would be 8 numbers up, and then 8 numbers up, and then 7 beyond that would get us to the 15th. So we would be in the 2 group, definitely. So our median in this case is just going to be 2. So our bar chart helps us to order our data and get our answer for that. So the mean, we just add up the number of numbers. So sum up, or add up, sum the numbers, sum of the numbers all over the number of numbers. And then again, we would be able to do this by adding up 0 plus 0 plus 0 3 times, plus 5 plus 5, sorry, plus 1 plus 1 plus 1 5 times, plus 2 plus 2 plus 2 15 times, and so on. But if I know that I have 3 zeros, if I'm adding up all of my numbers, that would mean I have 3 zeros plus 5 ones plus 15 twos, and so on, and then divide by the number of numbers which we added up our games for, or is 30. And when we put this into our calculator, we get 1.9 and 3 recurring. So this would be divided by a third if it was a fraction in all likelihood. And we can just put a dot over that. Now, what is the range of our data? Range is highest to lowest, so largest or biggest minus smallest, and that's going to be 5 goals minus 0 goals is going to be 5. So our range was 5. Now, these two are more reasoning questions. What is the maximum number of drawn games? So the maximum number of games that ended in a draw. Well, this isn't really a maths question directly. This is, say, a reasoning question. To get a drawn game, you'd have to have gotten an equal number of goals between both teams. So when could that happen? Well, you'd have to have an even number of goals so that both of them could have gotten the same, or you could have gotten no goals. So the 3 games that had 0 goals scored were definitely draws. So we have 3 plus these 15 games that had 2 goals scored. Well, each team could have scored 1, so that could have been all draws. 3 couldn't, 4. There were no games that it had 4. If there's an odd number of goals, then one team has to have gotten more goals than the other. So that means that the maximum number that could have been drawn games was 18. Now, that is not to say that all of these were drawn games. It's just that it is possible that they could have been. It's not eliminated by the number of goals scored, because we could, as I say, have had one team getting 1 goal, the other team getting 1 goal, and then in total we got 2. What is the minimum number of drawn games? Well, if we assume then that none of these games were drawn, in every single case one team got 0 goals and the other team got 2 goals, the only ones that have to have been draws is where nobody scored a goal. So that's just 3. What is the percentage of games that had a higher total score than the mean? Well, the mean was 1.93, so that is a bit less than 2. So the ones that had 2 goals scored and 3 goals scored and 5 goals scored would all count. So that would be 15 plus 6 plus 1 out of our total of 30 games. This would be the fraction of goals. So that would be 22 out of 30. That would be the fraction of goals that were that got scores, total scores higher than the mean, but we want that as a percentage. So what we need to do for an awkward one like this, where it's difficult to convert the denominator into 100 as we would like to if we were doing this purely by fractions, we can convert this on our calculator into a decimal, and we get 0.73 recurring, and that has a secret denominator of 1. So if I want to turn that into a percentage, I multiply above and below by 100. I want to leave that denominator of 100, so I'm going to multiply here by 100, and I get 73.33 out of 100 is 73.33%, and go to 2 decimal places if they don't tell you to do different. Finally, are there any outliers in our data set? And there kind of is. 5 is a little bit of an outlier. Most of these are fairly well grouped together around the mode of 2, but 5 would be a bit of an outlier. It is kind of off by itself. And that is what we need for now.